And here is the second video today. I've just finished a video on smart art going through third normal form, and this is many-to-many junction tables, composite keys for the January 2022 Washerpool College paper. So we'll talk about the importance of junction tables to resolve a many-to-many relationship. And in the case of this particular paper, because no primary key is given specifically for this junction table, and because you're not allowed to produce your own keys to add attributes to the flat file, therefore you must make a composite key of the foreign keys from the tables on either side. You're sucking in the foreign keys from either side to resolve the many-to-many. I'll explain that as we go. Washerpool College many-to-many. This paper gives us an example of needing to realize we need a junction table to resolve many-to-many. There are two tables that relate to each other, but both tables have a pk which repeats, and therefore each one must be a foreign key. So when you've got a many-to-many, you've got two foreign keys. Why don't we just put one inside the other table and skip the junction table? Well, I explain here why we can't do that. We could choose the leftmost table, pk1 from table 1, and put that into table 2 as a foreign key. But then when we do that, okay, that side can repeat of the many, so one many side is fine because it's a foreign key. But then that will be linked to a primary key because it's a one-to-many relationship with the one being the primary key. It would link to that one primary key which cannot repeat, and because it's many-to-many, you want to repeat both sides. You can't repeat both sides because one side's a primary key. So you can't do that. Okay, if we delete that relationship and foreign key and try again, go to the table on the right, primary key 2, table 2, put that into table 1. Okay, now we can repeat that foreign key side because it's a foreign key that can repeat. But the table you put it in still has a primary key that can't repeat. So if you try and do a one-to-many relationship when you actually have a many-to-many relationship, you'll try to repeat both sides, and one side is a unique primary key you can't repeat. So Access just won't allow it. The secret is a junction table with a composite key. The junction table needs to be made to house the composite key. So you have your two original tables, which are a many-to-many relationship, and you make a third table that is necessary to put in both many sides at once. Both many sides are at two foreign keys, and because in this exam you can't invent your own attributes, you've got to only use what they give you. If they don't give you a primary key for the junction table, you've got to make a composite key. Very easy, very straightforward. So here is the task scenario for Washerpool College. If we start highlighting it, we see that it is telling us directly we have three tables to start with: students, subject, classes, and it tells us which way they are organized. Students are enrolled into classes, so students to classes, and then classes for subject, so class to subject. So now we know the three ways they go. So if we put them in the same order as they are presented in the bullet points, yellow, blue, red, student, subject, class, that is wrong. We need to swap around the last two. So using the information that students roll into classes and classes are for subjects, we get this: student to class, class to subject. I have left a suspiciously big gap between student and class. Let's find out why. So first of all, we have found out at the bottom, highlighted in orange, a subject may be taught in more than one class. This means that subjects repeat for classes. Therefore, subject ID is a foreign key in table class, so that subjects can repeat in classes. So that is how we know that it goes table student, table class, table subject, and we already know which way around the one-to-many, and therefore the foreign key goes. Table subject's primary key, which would be subject ID, will give up a copy of itself as a foreign key to table class. The exam has directly told us already in the task scenario. We haven't even looked at the figure 1 flat file yet. Moving on. Here is the figure 1 flat file all colored in. So we know that everything called student goes in table student in yellow, everything called class goes in table class in red, and everything left is table subject in blue. Seems very easy, but if we just put it in like this, we won't be able to relate table student to table class. This is because they both repeat. So the red lines underneath class ID and student ID numbers show repeats. Both class ID and student ID repeat, meaning this is a many-to-many. There we go. I have now drawn arrows here to show you this is a many-to-many. This is not going to work for reasons I explained all the way back on slide 2. You can't repeat both sides in a table. You can only repeat even if there's a foreign key and primary key relationship within a table, because you can't repeat the primary key side. So we need to make a junction table. To resolve this many-to-many, we need a junction table. So I've broken the tables apart and I've put a junction table in between. That is called table student class. You could call it table enrollment because the scenario reminds you that students enroll into classes, but you don't have to, don't worry about that. So table student class, take the names of both tables that it resolves the many-to-many for. It contains each foreign key from both of those tables, so it will have student ID and class ID, and it will make those two foreign keys a combined composite key, which is very easy to do in Access. And this means we have this structure: table student junction table, giving up a copy of the foreign key; table class, the junction table, giving up a foreign key, copy of the foreign key. That's called table student class, that table. That table just has that in it. There's nothing else that fits in that table due to second normal form. There are no non-key attributes which depend on both sides of the composite key. So it literally is just a pure junction table, nothing else in it. It just has those two foreign keys. All it does is resolve the many-to-many relationship. And because both sides are foreign keys that are together, both a composite key, you can repeat either side. So you can say student ID 111, like Andrew, in class 1, 6, and 5. Because 1, 1, 1, 6, and 1, 5 are all different numbers when combined together. So that's how the composite key works, meaning the junction table can contain too many sides of the relationship, meaning it resolves the many-to-many by putting them together in a way where each side can repeat. That is the beauty of junction tables and composite keys. So if we put it all together, the yellow stuff is in table student, the red stuff in table class, the blue stuff in table subject, and the junction table, table student class, just has student ID and class ID. And this is what it looks like with an explanation of why this is the perfect exam board answer. So figure 1 gives us 3 obvious PKs, student, class, subject IDs. But we need 4 tables. This is because students are in many classes and classes have many students. Each student can be in more than one class and each class has more than one student. So there is a many-to-many relationship between student and class. Therefore, we make the junction table, and we could call that table student class, table class enrollment. The exam board answer calls it table class enrollment, but you can call it table student class, that is fine. All tables need a PK to meet first normal form. We could invent a new primary key, but if we did that, we'd lose marks because we must use all and only the attributes given in figure 1. So therefore, what we have to make a primary key out of are 2 foreign keys, and you can make a primary key from 2 foreign keys by making a composite key. This is why table class enrollment ends up with both student ID from table student and class ID from table class. These 2 foreign keys become a composite key in table class enrollment. So, and the question as to why table subject gives up a foreign key to table class, if we go all the way back to the beginning, the second slide, I think it was, the third slide, the task scenario told us that subjects repeat in classes, and that is how we knew that. You could also check it from having a look at the fact that subject ID repeats, so it's a foreign key. Table class is already giving up its primary key of class ID as a foreign key to table student class. So table subject, if subject ID is a foreign key, to make a relationship with table class, it must give up a copy of itself to make that relationship. I'll just quickly show you how to make the composite key in Access in case that's of value to you.